Welcome to Ask and Learn.
So in this problem, we're looking at xenon trioxide. Okay. So as always, when we're drawing Lewis structures, you put the less electronegative atom in the middle. You put the other three around it. Now, how many electrons do we have to work with? We have 8 from the xenon plus 3 times 6 from each oxygen. And so that is 26 electrons to work with. So the first thing we want to do is fill up all the octets from the oxygen. And notice I'm not even considering the number of bonds between the xenon and each oxygen for now. For now, I just want to make everything as happy as I can. So I filled up all the oxygen octets. That's 24 electrons I've used. I have 2 more left. I can put them on the xenon in the middle. Okay. And so this would be one valid resonance structure. Okay. I would have xenon in the middle with a lone pair and 3 oxygens, each of which is linked with um, a single bond. So let's look at the formal charges of this. Each oxygen has 1, 2, 3, 4, 5, 6, 7 electrons. It wants 6, so it's got an extra, so it has a negative charge. Xenon has 1, 2, 3, 4, 5 1, 2, 3, 4, 5 electrons. It wants 8, so that's a 3 plus formal charge. Let's see if we can make this better. Okay. And so we've started out by having 0 Xe and O double bonds. What if we add 1? How could we do this? We could take one of these lone pairs and shift it onto this double bond here, like this. Okay. Now, this oxygen, 1, 2, 3, 4, 5, 6, has 6 electrons, so it has a formal charge of 0. The other two still have a minus, and the xenon, 1, 2, 3, 4, 5, 6, it has 6, it wants 2, now it's at 2 plus. So this is a little better, right? Because it has fewer formal charges. What if we keep doing this? Add another double bond here. 1, 2, 3, 4, 5. Sorry, forgot the lone pair. 7, so that's a plus charge. This oxygen has a single charge. Okay, so we've looked at 0, we've looked at 1, looked at 2. Let's look at 3 double bonds. One, 2, 3, 4, 5, 6, 7, 8. So now this xenon that we have here, let's put them all together. Okay. So we've looked at 0 double bonds, we've looked at 1, we've looked at 2, we've looked at 3. All right. So we've considered all the possibilities, and this would be the answer to part A. Um, Now, do any of these resonance structures satisfy the octet rule for every atom in the molecule? Well, all of them do for oxygen because we have to do it for oxygen. But for xenon, the only one that satisfies this would be the first one. Okay. It has 3 single bonds and a lone pair. This one has a double bond, 2 single bonds, and a lone pair. That's too many. That's an expanded octet, and so on for these other two. This one obeys the octet rule. So I'll just put a B here to represent that as the answer to part B. Now, do any of the 4 Lewis structures have multiple resonance structures? Of course, right? So for the one with 0, there are no other resonance structures we could have drawn. But for the one with 1, we could have put the double bond On this oxygen, we could have put the double bond on this oxygen as well. And all three of these would have been would only have one X xenon and oxygen single bond. Sorry, would only have one xenon oxygen double bond. Similarly with this one, could have put the single bond on here, or on here. Okay. With the one with 3, there are no other oxygen. There are no other resonance structures we could have drawn. Okay, so this would be the answer. To part C. Do any of them have multiple resonance structures? Yes, these do. And I guess that's for completeness. This would be our answer to A. All right. Which Lewis structures, finally for part D, which Lewis structures have the most favorable charges? Well, this one has a ton of charges, and this one has none. And obviously you want to minimize the charges. This would be our answer. Part D. And that's the problem.